Greetings for the day. My name is MOHAMMED. Welcome to another session of computer networks. In today's session, we are going to learn about the TCP, or abbreviated as Transmission Control Protocol, as well as we are going to study about Userdatagram Protocol, also called as UDP. Now, in the previous session, we studied about the mobile IP and like the concept of mobile IP, how mobile IP is been implemented, and what is the process by which one of the network is been considered a home network, or what is the thing, or what is the network which is been considered as a foreign network. Now, how we will differentiate between foreign network and home network, and what are the different agents that helps us in transferring or with reference to transferring the information from one router to another router, the process of transferring the information and using the help of different types of agents and protocols to transmit that particular information. But in today's session, we are going to learn about the transmission control protocol. What actually is transmission control protocol? What is the need that we are using transmission control protocol, and what are the advantages with reference to other protocols? Now, coming towards TCP, TCP stands for Transmission Control. As the name suggests, that it controls the transmission of packets, it controls the transmission of segments, it controls the transmission of messages from one side to another side, or you can say from sender to receiver. The process of sending and receiving information is being controlled with reference to Transmission Control Protocol. Is been controlled with reference to Transmission Control Protocol. Now, what actually is Transmission Control Protocol? Transmission Control Protocol is process-to-process communication. It means it deals with one process to another process. We will see what the process is all about and how the process formation is been done and how the communication is been done. So, it deals with the process-to-process communication. It deals with one protocol to another protocol, or you can say one system to another system, how data is been transferred with a controlled way, how the data has been transferred in a controlled way. The second type, or second point, what it says is full duplex type of communication. If you remember, in the previous session I told you about simplex, half duplex and full duplex type of communication. Full duplex type of communication, it means we can receive the information and we can send the information parallelly. We can send and receive the information parallelly. And also I gave you an example with reference to simplex, half duplex and full duplex. Let me repeat so that we will refresh with those things. Simplex type of communication is a communication from which only one type of information is being passed. Considering the mic, considering a loudspeaker, these all are the simplex type of communication from which only from one side of the part the information is being flown, and one side of the part the information is being received. It means it is only one type of communication. It is only one type of communication. This type of communication is called as simplex type of communication. Now, coming towards half duplex type of communication, if you see the walkie-talkie, it is half duplex type of communication in the sense it can receive and send the information but one at a time. In the sense, if at all someone is sending the information to you, you are able to only receive the information, you cannot send that information parallelly. It means when you see a walkie-talkie, either you can speak or you can listen. You cannot speak and listen simultaneously. In the same way, this type of communication is called as half duplex type of communication. Now, coming towards full duplex type of communication, let you consider the example of a mobile phone. You can receive and you can send. Both the things you can do parallelly on a mobile phone. Like if at all someone is speaking, you also can speak as well as you can listen. This type of communication is called as full duplex type of communication. But here, full duplex type of communication means you can send and receive information parallelly at same instance. The next point is connection oriented services. Now, what do you mean by this connection oriented services? It means it is relied on connections. It is a connection oriented type of protocol which helps you with the help of reliability. Now what reliability is there, we will study in the next point. Now the next one is stream oriented protocol. It means it streams with reference to bytes. If at all, if you remember, with reference to the memory sizes ranges from bits to bytes, kilobytes, megabytes, gigabytes and petabytes. Not gigabytes, terabytes and petabytes. This is how the memory stack goes up. Now here the transmission control protocol streams the byte. It streams the byte. 1 byte is equal to 8 bits. This is for your information. 1 byte, byte is equal to 8 bits, bits. Okay. Remember this will help you in your other subjects. In your other subject, this will help you to remember other things. Now the next one is segmentation. Now what do you mean by segmentation? Segmentation in the sense, when a packet is been received, it is been distributed equally, so that when a packet has been transferred, or when information is to be passed, when a packet is to be delivered, it is been delivered in respective packet size. In the sense, for an instance, if at all there are 100 students to be given for examination, what you will do? You will be dividing 10 students in each class. It means 10 students in each class means how many classrooms you need? You need 10 classrooms for 100 students. So in the same way, every of the packet is being segmented with reference to bytes or with reference to what you call as the data it received. That is what you call as datagrams. This segmentation part of data is called as datagrams. Okay. Now datagrams in IP or IP layer. The next one is utilizes buffer at both ends, flow and error control. Now what do you mean by this flow and error control? Flow and error control in the sense, when I am speaking, if at all if I fumble or mumble for something, I will repeat it so that you can understand it in a better way. That is what we call as flow. And what do you mean by error control? Error control in the sense, if at all if I mistakenly say something, then I say it again to rectify it, that is what we call as error control. Or in other words, I can say, if at all some packet has been misplaced, I need to redirect that packet again so that correct form of packets or correct form of information is received at the receiver. That is what we call as flow and error control. The next one is reliable. Reliable in the sense, how you will be relying. Like for an instance, what is the criteria to be reliable? Reliable has some criteria like this is to be followed, then only you are reliable. If at all if you say a truth, if at all if you are doing the work at time, you are not reminded every time to submit the assignment and all these things. If at all if you are doing it by yourself, then it means you are a reliable person. You are a reliable person. In the same way, when it comes to computer networks, reliability means when you are sending some of the information, you are getting some of the acknowledgements. When you are sending some of the data, you are getting some of the acknowledgement. That is the reason this type of protocol is reliable. When I am saying something to you, you are responding to me with reference to my messages. If at all if I am saying hi, you are saying hi back to me. If I am saying hello, you are saying good morning to me. If I am saying good morning to you, you are telling me the questions like, sir, this is the thing that you need to explain today. I am getting some of the acknowledgements from you. It means this type of communication is reliable. Why? Because it is a two-way type of communication in which I am also speaking, you are also speaking, and also you are giving me some of the acknowledgements. This type of communication is called as reliable communication. Now we will see how this acknowledgement part will come into picture and how we will be able to implement this acknowledgement part in TCP/IP, like TCP, not IP, TCP mechanism or TCP things. Now the next point is TCP seeks to deliver a byte stream from end to end in order and reliable. In the sense, for instance, as I have told you, there are 100 students to be written for the examination. I have divided 10 students for each class. Now, for an assumption, you can assume like those 10 students can be random. Those 10 students will be divided with reference to the roll numbers. Those students can be selected randomly, or those students which are compatible to sit in any of the class can sit. It means any of the case can happen. In any of the case, you are not able to say which student is sitting in which class. Why? Because you don't have proper order of students. If at all attendance sheet comes, roll number 1 is sitting in classroom 1, roll number 2 is sitting in class 10. So this is very difficult to get the attendance. This is very difficult to get the attendance in a sequence. So it means you should be following a sequence. The system must be in order as well as the system must be reliable. For instance, if at all someone is absent, and 101 student come, like 101 student come and sit in the examination and write the examination, he has been considered as 100 student, but actually he is 101. But 99, rule number 99 student is absent, so he should be marked as absent. And roll number 101 should be marked as present in the next session. So reliability and order should be maintained, and in this protocol it maintains order and reliability with reference to sending and receiving of the data. Now how this has been done? This has been done with reference to an acknowledgement, data or acknowledgement type of packet, which confirms that I receive this particular information, or my computer or my data has received every of the complete information with reference to the information that we have sent. That is what it is been said in this slide. Now coming further, what it says, the TCP features. What are the features of TCP? TCP follows some numbering system, so that to maintain the order of the packets being sent and to maintain the orders of packet to be received, and also to maintain the number of packets received and to maintain the number of packets that is been lost. Okay, for that purpose we will be maintaining a numbering system. Now what it says, byte numbers. As I have told you, this is maintained in byte numbers. Now what is the third point? TCP numbers all the data bytes that are transmitted in a connection. When you are sending any of the student in the class, roll number 1 to 10 in class 1, roll number 11 to 20 in class 2, roll number 21 to 30 in class 3. This is how I am dividing them into different segments and also in different data classes. Or class 1 is a data set of roll number 1 to 10, roll number 1 to 10. Class 2 has a data set of 11 to 20. It means this numbering will help you to transmit the connection. So what it says, TCP numbers all the data type that are transmitted in a connection. Now what is the next point? It says numbering does not necessarily start from 0. It can be any random number, but the interval that is being maintained should be with reference to the size that is being sent. For instance, you are sending 10 bytes of data, so the first numbering is starting from 200. 201 to 210 is the size or the numbering for the TCP. It means if at all I am sending 10 bytes of information, the receiver should receive 10 bytes. That 10 bytes has a numbering 201, 202, 203 until 210. Now, after the receiver receives the packet 210, this receiver will send a confirmation to the sender that I have received the packet from 201 to 210. Is this correct? Or I have received this packet. After the receiver receives this, if at all if there is some mistake in that, then those packets is been again retransmitted. That packets are being again retransmitted. If at all there is the information that is been sent from the sender and the receiver has received the same information, then no need of retransmission. It means the receiver has received every of the packet that is been sent from the sender. Okay. Now next one says TCP generates a random number between 0 to 230 232 minus 1 for numbering first bytes. Okay, random numbers can be anything. Let us consider like 3, 4, 2, 3. Any random number. Total bytes is 5000 of bytes we are sending. So what is the range? The range is 3423 to 8422. This is the size, like this is the range from which the packet is to be received. I hope like you understood, like you are with me and you are understanding the thing what I am trying to say. This is very simple actually. This is all about your what you call as like how I can say, with reference to the snake and ladder type of thing. You roll a dice and the number that you get, you move forward. The same thing is happening over here. You will take a random number and you send the packet with the size and you move forward, and the receiver will receive the information along with that size. Now moving forward, it says TCP figure has an acknowledgement number, defines the number of the next byte that the party expects to receive. It is cumulative acknowledgement like 5487. It means it has received all bytes from the beginning to 5486. Here it is 5487, here it is 5486. In the sense, why it is 5486? Because it is starting from 0. It is starting from 0. Okay. Now coming further, what it says, control flow or flow control. What it means, receiver of the data controls the amount of data that are to be sent by the sender. It means the amount of information that is to be sent is controlled. Now what do you mean by this control? For an assumption, you assume like there is a passage or there is an highway and it has got a V-neck type of things, like there is a highway and it is getting narrower to a V shape, and there is a bridge on which there is only 2 tracks. On this there is only 2 tracks. Now at this instance, only one bike from one lane can move forward. So what it will do? It will be segmented. It will be segmented so that there should be no congestion at the bridge. Also the traffic should be moving in an efficient way. When the road is getting narrower, the car comes one after the another, so that the traffic movement can be simpler. Now consider this one car as one segment. Consider one car as one segment. Now here the TCP controls that particular path. The TCP controls that path with some limited byte size. So that it can be transmitted easily without any congestion. Now what is the next point? It says numbering system allow TCP to use byte oriented flow control. Okay. Now the next one is error control. Error control in the sense, consider a segment as a unit of data for error detection. What do you mean by this? You have sent 10 packets and I have received only 8 packets. It means there are 2 packets that is missing. So for these 2 packets, again the confirmation is being sent with reference to the acknowledgement number that these packets are missing. Retransmit that packet again to me. So the sender will again send you the information, or he will retransmit the information so that you will receive all of that file. Okay. For an instance, I will give you an example how these things will happen. Okay, just for an idea I am telling you how these things will happen. If you open any of the website, and the website is opening and it is still not open completely, if you click on any of the icon, it will not open. But because all of the packets are not received correctly to process that information or to process that task. After all of this information is been received on your website, then only you can click on any of the link. Observe it. If you have not observed it. Why? Because this is with reference to flow control as well as with reference to error control. And in some instance, if you open Facebook or any of the website will not be sorted. When you refresh it, the website will come in a correct format. How this is happening? It is happening with reference to flow control and error control. At the first instance, when the screen was shown, it was distorted. It means there was some error. When you refresh this, again it has requested the server to send the packet again so that the screen can be again refreshed and correct screen can be replaced with the what we call as fluctuated screen. So this is what we call as error control and flow control type of things. The last one is congestion control. It controls the congestion. As all like I have told you, it sends some limited packets so that there should be no congestion in the on the network. Now this is how a three-way handshake protocol or three-way handshake things comes into picture. What do you mean by this three-way handshake? Three-way handshake means we both want to start a conversation. So what I'll do, I'll say hello. You will listen hello. In response to that hello, you will be sending me some response saying like hello to you or hi, and again we'll start our conversation. This is how the conversation starts. In the same way over here, if you see what is happening over here, I am sending some synchronization saying some I want to establish a connection with you, or I want to start a session with you, or else I want to have some of the data from your side. So I am sending some of the synchronization. So in response to the synchronization, the server is sending an acknowledgement to me saying that I have received your information. I have received your information for synchronization, and I am responding to your synchronization along with this acknowledgement. Now from here they can start the conversation. Now here the information is being passed again to the server to get the information what is being requested. This is how a connection is being established with three-way handshake protocol or three-way handshake type of connections. This is how things will work. Client server, I am saying some synchronization to you, you are giving me an acknowledgement back, and we are having a session along with this. This is what we call as three-way handshake. Now what are the terms with reference to this three-way handshake? We are going to see. SYN represents synchronization. It is for synchronization of sequence of numbers. It consumes one sequence number and carry no real data. In the sense, this is synchronization in the sense this is just for establishing a connection. This does not send any of the data. Data in the sense it doesn't mean like the actual data. This synchronization can also mean with reference to for an example I'll give you. If you want to open any of the website or Gmail server or Yahoo server, anything, you send your credentials, not your data. You send your details with your credentials like username and password for an acknowledgement, and along with that he will give you a home login page. When you are clicking on, when you are writing username, password and clicking on login, with that data, that server is returning you the home page along with all of the links possible to process that website. That is what we call as synchronization. Now what has been written is called as synchronization with acknowledgement. Synchronization segment for communication in another direction, and acknowledgement for the server, acknowledgement for received synchronization. In the sense, if at all we observe here we have synchronization along with acknowledgement. Now the last one is ACK. It is only the acknowledgement. Just carry an acknowledgement segment does not consume any sequence number, because as we have started with reference to the conversation, or we have started with the session, here it does not consume any sequence number. This is with reference to the connection and establishment with reference to three-way handshake type of connection. Now moving further, what it says, flow control in TCP IP. What actually is flow control with reference to TCP, not IP, sorry, I am repeatedly saying IP, it is only TCP. TCP uses sliding window to handle flow control. The size of the window is determined by lesser of two values, RWND and CWND. What do you mean by this RW? R for receive, C for congestion. See, there are two ways by which we decide the traffic. The first one is with reference to the number of vehicles available on that spot, and second way is the possible timings on which there can be the traffic. There are two things to analyze the traffic. In the same way, here RWND is the number of bytes that receiver can accept before it buffer overflows. Buffer overflows means there will be some limited size into which the data will be sent. If before that get overflow, it will stop, or it will analyze the number of bytes the receiver can accept before getting overflow. The second one is congestion. It is the value determined by the network to avoid congestion. It means one car at a time on the bridge, on one lane. This is the rule for avoiding congestion. If at all two cars goes on that lane, there is a chance that congestion can happen. There is a chance that congestion can happen, but it is not sure that congestion can happen, but there is a chance that congestion can happen. And the last point is the receiver controls most of the aspects. Okay. Now moving forward with reference to error control, what error control is. Error control includes the mechanism for detecting corrupted segment, lost segment, out of order segments and duplicated segment. What do you mean by this? Error control in the sense, as I have I am saying hello to you and you are listening hello for 3 times, 4 times or 5 times. This is disturbance, this is noise, this is error. I am sending hello to you, you are receiving hi. This is also what you call as error segment or corrupted segment. This should not happen with reference to transfer or transmission of in TCP mechanism. For instance, I am sending an email of a link of downloading the computer network's textbook, but you have received some of the other link with reference to Google. So it means there is some error in the link. There is some error in the link. You will say, sir, you have sent a wrong link to me, please send the correct link. It means either it is a corrupted segment, or it is a lost segment, or it is out of order segment. Out of order segment in the sense, you have sent 10 what we call as data packets or datagram. You have not received 8 packet. You have asked for retransmission. You got the retransmission, but the actual file is coming now. It means it is out of order segment. It is out of order segment also means first you have received first, then third, then second, fifth, eighth, ninth. Now this should be ordered. If at all is not able to order those things, then error can happen. Error can happen. So to control that, a segmentation should be done so that the path or the order should be followed in receiving and sending the information. The next one is achieved through the use of 3 simple tools. What is the 3 simple tools? Checksum, acknowledgement and retransmission. Checksum in the sense you will be adding some extra bit to that sent packet so that when the receiver is receiving that packet, he should be acknowledged with saying that checksum that I am receiving the correct packet. After the packets have been received correctly, you will be sending the acknowledgement. If at all the packets are not received in order, we will be asking for retransmission. This is what we call as the error control with reference to the transmission control protocol. I hope you are able to understand what I am trying to say. Checksum, acknowledgement, transmission. Checksum is an extra bit added to the packets. Acknowledgement is something like after you receive that particular packets, you send an acknowledgement, I have received these particular things. Retransmission in the sense, when you have not received any of the packet, when there is a delay of the packet, when there is a loss of packet, when there is a duplication of packet, I will send an acknowledgement that to retransmit that original packet again to me so that my file can be received correctly. My file can be received correctly. This is with reference to error control in TCP or transmission control protocol. Now what do you mean by checksum? Checksum means each segment includes a checksum field used to check the corrupted segment. Now the way I spoke, I made a mistake. Means the information that I am saying is being distorted. It is being distorted in such a way you are not able to understand. So what I need to do? I need to say it again. So it means it includes a checksum field used to check the corrupted segments. To say the corrupted segments. The next point is TCP uses a 16-bit checksum. And the last point is corrupted segment is discarded by destination and is considered as lost. This is with reference to checksum. The next one is acknowledgement, confirms the receipt of data segments. Control segment that carry no data but consume the sequence number are also acknowledged. The last one is acknowledgement segments are never acknowledged. What do you mean by this? It means this is just to confirm. This is just to confirm, not to be transmitted. This is to confirm, not to be transmitted. Okay. Now the last one is with reference to the transmission or retransmission. A segment is retransmitted on 2 occasions. When the transmission timer expires, like if at all if I am saying hello, you are receiving hello after 1 hour, 2 hours, 3 hours, it means the time by which it should come, it is not coming. It means the transmission timer has expired. For that reason also transmission can happen. The second reason is when the sender receives 3 duplicate acknowledgements, like receive, then also transmission happen. There is no transmission of acknowledgement segment. As I have told you, retransmission after RTO. TCP maintains one RTO timer for all outstanding sent but not acknowledged segments. When the timer matures, the earliest outstanding segments is retransmitted. Value to RTO is dynamic and is updated based on RTT. This is with reference to the retransmission of the data in reference to TCP. Now coming towards the next protocol, that is Userdatagram protocol. Now when we are talking about UDP, the comparison is always with TCP. When we are talking about UDP, the comparison is always with, when you are talking about TCP, comparison with UDP, when you are talking with UDP, comparison with TCP. Now what it says, in TCP IP protocol suite, using IP to transport datagram. Okay. Second one is allows the application to send datagram to other application on the remote machine. This is a connectionless type of a protocol. Delivers and duplicate detection are not guaranteed. Lower overhead, faster than TCP. Now, to explain you this, I will give you a small example. These, like everyone can relate to this. See, when you are buying a new bike, there are 2 things in your mind when buying a new bike. The first one is either you want it for the speed. The second one is either you want it for the mileage. There are 2 things in your mind. You will see to that I want greater mileage, you go for the greater mileage. If you want greater speed, you will go for the greater speed bikes. In the same way, TCP will provide you with reference to the acknowledgement. This is with reference to your mileage. Whereas UDP is with reference to just transferring the packet from one side to another side or from sender to the receiver. This has a faster rate with reference to TCP. This has faster rate with reference to TCP. Now moving forward, what are the characteristics of UDP? End-to-end, an application sends receive data to from another application. It is connectionless type of a protocol in which application does not need to pre-establish communication before sending the data. Application does not need to terminate communication when finished. It means it doesn't have any acknowledgement type of a thing. Just you send the thing, you have sent the thing. Whether the receiver receives it, whether that packet has been what you call as lost, whether the packet has been duplicated, that's another case. But the only thing is like you have sent the packet. The next one is message oriented. Application send receive individual messages, UDP datagram, not packets. Okay. Now best efforts, same best effort delivered semantics as IP, that is message, can be lost, duplicated and corrupted. And the next one is arbitrary interaction. Application communicates with with many or one other application. Okay. The last one is operating system is independent. Identifying the application does not depend on OS. Now the next one is like what do you mean by identifying your application? UDP cannot extend IP addresses. It means no unused bits. The next point is cannot use OS dependent quantity, which means process ID, task number and job name. The next point is must work on all systems. Like this UDP will work on all systems with reference to the IP that we are using. What are the techniques? Each application assigned has a unique integer called protocol port number. Now I hope you understood, you are with me and you are understanding what I am trying to say. What actually is port protocol number? UDP uses port number to identify an application as an endpoint. UDP messages are delivered to the port specified in the messages by the sending application. What it is, in general, a port can be used for any datagram as long as the sender and the receiver agrees. Here, sender and receiver should agree for communication, and that's it. The sender will send the information. Whether the receiver receives it, the packet has been lost or the packet has been duplicated, nothing like acknowledgement type of things in UDP. In practice, a collection of well-known ports are used for special purpose such as telnet, FTP and email. Example, port 7 for echo application. And the next one is local operating system provides an interface for process to specify an access port. Okay. Now this is with reference to the TCP and UDP type of protocol. I hope you understood something from today's session. If at all, if you have any doubt with reference to today's session, please let me know on my email address hemant_ali2u@outlook.com. If at all someone wants to get some of the notes, please ping me. I'll reply you with the link so that you can get the notes or you can get the material for studying for your subject. That's all for today. I hope you understood something. I wish you all the best for the day and all the best for the time. Thank you for joining and thank you for listening. See you in the next session. Thank you.